Okay, example 1 here in these practice problems. Find the indefinite integral of 1 over the root of 81 minus 121x squared. Now, like I said in some of the other videos, you want to consider all of the other antiderivative techniques that we've done in this class, but clearly this one is going to involve inverse trig, and you can see that it's going to involve inverse sine. So let me just note what the antiderivative is involving inverse sine. So it's the integral of du over the root of a squared minus u squared is equal to arc sine of u over a and then plus c. So I would look at this and say, okay, my a squared is 81, making a equal to 9. And my u squared is equal to 121x squared, making my u equal to 11x. Because 11x squared would give me 121x squared. Now, we still have to do a du, because remember, we're going to convert this into the integral of du over the root of a squared minus u squared. So du would be 11 dx, and you have some adjustments to make. We need to multiply this by 11 in the inside and 1/11th in the front. But then this integral becomes, now I can rewrite this as 1/11th times the integral of du divided by the root of my a squared minus my u squared. So this is 1/11th times the arc sine of u over a plus c. And so we just have to back substitute in for u and a, and then we're done. So the answer is 1/11th times the arc sine of 11x over 9 plus c. And so this is going to line up with which one of these choices? It looks like it lines up with c. 1/11th arc sine of 11x over 9 plus c. Example 2. Now, again, you would go through your checklist of all of your other things before you arrived at the fact that this is going to involve inverse secant. Since we do know here that it's going to involve arc secant, let me just note the formula. So the integral of du over u times the root of u squared minus a squared, that's going to equal 1 over a arc secant of the absolute value of u over a plus c. Okay, so 256x squared is my u squared. So if that's the case, if u squared is equal to 256x squared, then you could do the square root of 256 and see that that's 16. So then u would equal 16x. Likewise, my a squared is 81, so a is equal to 9. My du is going to be 16 dx, which we do not have here, but I can adjust. And so we end up with 1/16th integral of du all over. Now, at first we don't have our u down there because it's just the x, but don't we want a 16x to be right there? So we can steal this 16 and put it in there right next to the x, so that we actually do not have a 1/16th in front anymore. Instead, we actually have, the, I should probably maybe even just write it like this. Let's just write it as the 16 is directly in front of the x. And so that way, this is u square root of u squared minus a squared. And so our answer is, it's 1 over a arc secant of absolute value of u over a plus c, because this is exactly the formula. And we just have to back substitute in for a and u. So this becomes 1 over 9 times the arc secant of the absolute value of 16x over a, and a was 9. And then again, that's plus c. So this is going to be choice, what is this? This is choice E. 1/9 arc secant absolute value 16x over 9 plus c. Okay, last practice question. Definite integral. And again, This one's going to involve inverse trig because notice if you try to use sub for that denominator, you don't have a du that involves an x. And if you let u equal 9 plus x squared, you would need a du that involved an x, and we don't have that. So to me, this looks a lot like the inverse tan antiderivative. So I'm going to write this down. I'm going to say the antiderivative of du over a squared plus u squared is equal to 1 over a arctan of u over a plus c. The other thing I'm going to do is I'm going to take that 13 and I'm going to bring it out to the front before I get started. I could see that kind of making my life a little bit difficult. So I'm going to start like this with the original problem. And so if I do start like that, then I'd say, okay, so it looks like my a squared is 9, so a is equal to 3. And it looks like my u squared is equal to x squared, so u is equal to x. Which means du is just going to be dx. And so this problem becomes 13 times the integral. Now remember, we're going to change this in just a second. Of, what do we have? Du over a squared plus u squared. But let's change everything to be in terms of u, including these limits of integration. So if x was root 3, oh, well, u is equal to x, so this is still going to be root 3, and this is still going to be 3. And then, according to our formula, will lead us to 13 times 1 over a, and I can actually fill in what my a is now, times the arctan of u over a, and that is where my u is going from 3 down to square root of 3. So we end up with 13 thirds multiplied by the arctan of 3 over 3, so that's the arctan of 1, minus the arctan of root 3 over 3. Okay, so let's try to recall a little bit about our trig. When you're doing the arctan of 1, you're saying the tangent of what angle is equal to 1? And the answer to that is pi over 4. And then here, when you're doing the arctan of root 3 over 3, you're saying the tangent of what angle is equal to root 3 over 3? That's 30 degrees, or pi over 6 radians. And so we just need to simplify this a little bit. And you know, you could, if you wanted to, you could punch this into a calculator, get a decimal, and compare to what these decimals would be. But we could quickly get a common denominator here. You could say that this is 3 pi over 12, this is 2 pi over 12. So this would become 13 thirds times, what did I say, 3 pi over 12 minus 2 pi over 12. So that would be pi over 12. So we end up with 13 pi over 36. So I think the answer is C. Okay, so hopefully this helps, and now you can tackle that final homework assignment before you get to start reviewing for that final exam.